All right, good morning, everybody, again.
Good morning.
Let's see here, where my pen go. There it is. All right. So, kind of like I did in first period, I'll just kind of field questions that you guys might have in general first, and then if we sort of run out of those, then we can move on and just work on some of these problems. Some people's questions were on some of these problems that I sent out last night anyway, so we worked through a few of those during first period. But might as well get started. So, anybody have any questions in general about the test, in general about calculus, or any specific questions on any of the problems I've sent out recently? All right. Let's see here. So Molly, let's do this at the end of this here. So Molly, you're talking about if you have a differential equation that's dy dx equals y plus 1, is that over? Yeah, over x plus 1. So when you separate your variables, you've got dy over y plus 1 equals dx over x plus 1. Both of those can be simple u substitutions to integrate both of those. And they both come out to be natural log absolute value y plus 1 equals natural log absolute value x plus 1 plus your constant. And then nothing happens to the absolute value signs right off the bat. What we'll do is we'll raise both of these as powers of e, so we'll exponentiate them both. You get absolute value of y plus 1 equals e to the ln absolute value x plus 1 plus c, which is the same as e to the natural log absolute value x plus 1 times e to the c, which just gives us absolute value y plus 1 equals e to the c, which is just a constant. We'll call it k, let's say. K, absolute value of x plus 1. And then the absolute values are still there at this point, but when we clear them off, we know that this could become plus or minus. So basically you just get rid of them and make it that this absolute value of y plus 1 should be equal to k times plus or minus, well, we'll call it plus or minus x plus 1 here. And we'll call this plus or minus y plus 1 here. And then you have to use whatever initial condition is given to you to determine whether or not you're supposed to use the positive or the negative version of that absolute value. So I don't know where you got that problem from, Molly, but whether it had an initial condition or not. Okay, the point was -1, 3. Okay, so plug in -1 for x. First we should have found this constant. So we'll go back and do that. But if we plug in -1, that gives us natural log of if you plug in -1, you can't do that because you got a natural log there. Okay, x was 0, so 0, 3. Is that the original point? Okay, so if we plug in 0, 3 into our original, once we took our antiderivative, natural log of absolute value of y plus 1 gives us natural log of 4 equals natural log of 1 plus our constant, and our constant is ln 4. So what we end up with here then is e to the ln 4, which is just 4. So this is just y plus 1 equals 4 times x plus 1. And we just need to go in and put the right signs in here. So if x was 0 and y was 3, this works out perfectly with just making the positive versions of it. So that's what we'd want to use. But if you had different values in there, one of them was like a negative or something, you'd have to use the negative version of it. Does that make sense? All right, Sean, on the AB2 test I sent out, can I explain how to solve 1D? So the second, I'm gonna go back through here and make sure I get the right problem for you. What do you mean, Adrian? How do you know? Oh, that they're both not negative? If you made them both, well, it's not going to change. K is not going to be a half. K is still going to be 4 because you want to solve for your constant as soon as you take your antiderivative, you're going to solve for your constant. But I believe if you made them both negative in this case, what'll happen is it'll come out to be the exact same thing because you'll just rearrange the sides that each one of them is on, and it'll come out to be the same basic equation. Yeah, it's multiplied by that because of exponent rules. So e to the a plus b, right? If I have e to the a plus b, that's the same as e to the a times e to the b, right? If you add the exponents. And so that's what I have here. I have e to the a plus b. So that should be e to the a times e to the b. Okay. All right. Okay, Sean, I'll go back to that now. So the second test that I sent out, and you said number 1D. Is that this one right here? Okay. So we're looking for m prime of x. So if we're looking for m prime of x, that's the derivative of this derivative of the integral from 0 to 2x. So first off, let's simplify the expression for m of x. So m of x is equal to the derivative with respect to x of the integral from 0 to 2x. And let's call that the integral from 0 to just a single constant, or sorry, a single variable. So let's call that the integral from 0 to u, with u equal to 2x of g of t dt. And so when we take the derivative of the integral from 0 to u, from 0 to a variable of this function, we just get this function, g of u. But since we're taking the derivative of something that's in terms of u with respect to x, we have to multiply that by du dx using the chain rule. So du dx is 2. So this gives us 2 g of u, and u was 2x. So this gives us 2 g of 2x. And that's just what m of x is equal to. So m prime of x should be equal to the derivative of 2g of 2x, which is 2, times the derivative of g of 2x, which is g prime of 2x, times the derivative of 2x, which is 4 g prime of 2x. And so we're looking for m prime of 2.5, which means we're looking for 4g prime of 2 times 2.5, which is 4g prime of 5. And I believe earlier in the question, you were asked to find g prime of 5 for part A. G prime of 5 is just the derivative of g, or the slope of the tangent line of g at 5. Well, it tells us that this is the line tangent to g at x equals 5. So that slope is negative 5/3. That's what g prime of 5 is. And so we'll just go back in and say this is 4 times negative 5/3, which is negative 20/3. fairly long one there to get that. And then that result is useful later on when you're trying to do part E, I think, and part F, maybe. I can't remember. We did them last period, but does that make sense, Sean? Yeah. Yeah. Good. Other questions there? Anybody else have any questions at the moment? Okay. So since it doesn't sound like there's a bunch of specific questions at the moment, what do I think the best way to take the test would be, Nick? If I had, yeah, personally, I would just do it on paper if it were me, but that's just me. I don't like writing stuff on the computer and trying to worry about all the, the keyboard shortcuts and all that junk. I don't like doing that. I'd rather just write it out and take a picture and upload it personally. But that's why I suggested you guys go in and do that demo and, make sure you understand how it all works and make sure it all works properly for whichever way you do it. I suggest paper. At least that's what I would do if it were me taking it. So. All right, let's look at, oh, Jordan's got a question here. Okay, on 2015 FRQ, question 4D. So we've got dy dx is equal to 2x minus y, and we know that y equals mx plus b is a solution to that differential equation. So let's see here. We want to find the values of m and b. So the first thing that we'll want to do with that is just to take the derivative. So if y equals mx plus b is the solution to that, then dy dx should be the derivative of this, and the derivative of y equals mx plus b is just m. And so we know then that 2x minus y should be equal to m. And we can then go back in and replace the y value. 2x minus y is, since y is equal to mx plus b, we've got 2x minus the quantity mx plus b is equal to m. And from there, it's kind of a matter of getting this m over here and solving, or setting it equal to 0 and solving it. So I'm going to write this out as 2x minus mx minus b minus m is equal to 0, which tells us that 2 minus m times x minus b plus m is equal to 0. And so this is kind of like, well, I don't know if you guys don't know partial fraction decomposition, but that's fine. It's kind of similar to that, which many of you will do next year. But if we look at the right-hand side of this, we can say that there are 2 minus m x's on the left-hand side, and there are 0 x's on the right-hand side, which tells us that 2 minus m has to equal 0, so that I have the appropriate number of x's over here, 0 x's and 2 minus m x's. And then also I need b plus m to equal 0, because I have no constant over here. The constant is 0, and so this constant on this side should also equal 0. So this tells us that m equals 2, and if m is 2, then that tells us that b is negative 2. Does that help, Jordan? Yeah, it's not partial fraction decomposition. I said that. It's a similar idea. Like when I have this, an idea behind partial fraction decomposition is you're looking at how many x's are on the left hand side and comparing it with how many x's are on the right hand side, and then writing yourself a system of equations, kind of like we did here, using that. But you don't actually have to use partial fractions. Just recognize that there are 2 minus m x's and 0 x's. So the number of x's on both sides has to be equal. So 2 minus m has to equal 0. And then the constant on the right, which is 0, has to equal the constant on the left, which is b plus m. Does that make sense, Jordan? Okay, cool. Molly, with integrating, let me see here, Molly, would integrating dy dx work as well? Well, no, for 2 reasons. 1, because you're right, there's no initial condition. That'll make things more difficult. But 2 is you're not going to be able to integrate this using separation of variables because it's a plus or minus between them, not a multiplication between them. And there's a way to do that, but it's not something that you learn about in either Calc 1 or 2. So no, you won't be able to do that. Adrian, does it say something or show something if you upload a picture from the demo you didn't see it? I don't know. I haven't seen anything that says that it should verify that you did. Maybe somebody else in here can answer that. Did anybody upload a picture in the demo and it showed up? Yeah, Kiana says that it should, Adrian. So I'd go back through and take a look at that again and make sure that your stuff is actually uploading.
Can I turn to the next page?
All right, does that help, Adrian? It looks like everybody's given you the info you need. All right, I'll let you guys sort that out. Sean, you want to do 1E for the AB number 2 test, which, let's see here.
Do it.
Yeah, Max, go forward one here.
Forward one?
Yeah. Max is going to help us out again today. Maybe. Perfect. All right. I don't know. There we go. Okay. So E here, Sean, is asking us to use the mean value theorem. And so for those of you that, we did this one during first period today, but we'll do it again, even though some of you are back for the second half here. We're asked to use the mean value theorem at 2.5 on the interval 1 to 4. So the mean value theorem applied to M says that M prime of 2.5 should equal M of 4 minus M of 1 over 4 minus 1. So we need to find M prime of 2.5, which I believe that's something we'd already done in part D. So M prime of 2.5 had come out to be negative 20 over 3. So we end up with negative 20 over 3 is equal to M of 4 minus M of 1 over 3. Gives us that negative 20 is equal to M of 4 minus M of 1. And so then we have to go back in because we're not interested in what's going on with M. per se. We're interested in what's going on with g of 8 minus g of 2. But we know that m of x is equal to, over here, 2 g of 2x is m of x. So we can say that negative 20 equals 2g of 2 times 4 minus 2g of 2 times 1 by replacing, m of x is equal to 2g of 2x from when we were finding m prime earlier. We can divide both sides of this by 2, which gives us negative 10 equals g of 8 minus g of 2, which is what it asked us to find. Does that make sense, Sean? Cool. All right, so we've done A, D, and E from that question. I think this is a pretty good question to look through. So let's quickly look at B and C also, just to make sure everyone's okay with those. If B is 2x squared g of x, then we should be able to use the product rule to find B prime. B prime should be 2x squared g prime of x plus 4x g of x. And if we're evaluating that at 5, this should be 2 times 25 times g prime of 5, which is negative 5/3, plus 4 times 5, which is 20 times g of 5, which is 1. And bother to do the numeric simplification because you don't need to on the test. Everybody good there with B?
No.
Okay. And for part C, same idea. We're finding W prime given this is W. And we are you're going to use the quotient rule for this one. So this should be W prime is equal to 2x plus 1 times 3h prime of x minus 1 minus 3h of x minus x times 2 over 2x plus 1 squared. And you'll plug in 5 again for this. So that's going to give us 11 times 3h prime of 5. And h prime of 5 is also negative 5/3. Same idea as the other one. So 3 times negative 5/3 minus 1. And then minus 3h of x. And h of 5 is 1. So this is minus 3 minus 5 times 2. And then our denominator there becomes, what is that? 11 squared is 121. Once again, you don't have to simplify it down if you don't want to. Just leave it like that. Any questions on C? Or everybody good with that? All right. We want to finish this problem up and do the other parts or no? We've now done A, B, C, D, and E. I don't think we had done F yet, had we? Okay. So, okay, we did F in first period, but we'll do it again here. So we're given the fact that L'Hopital's rule can be used to evaluate this. Yes, Sean, leaving it unsimplified is fine. That's one of the things they put out in the notes. You don't have to simplify numeric answers. Algebraic stuff, simplify. Numeric does not need to be simplified at all. All right, so if this can be evaluated using L'Hopital's rule, I'm going to give us another page right here so we have some more room to work on this. We've got g of x is, what is it equal to here? X plus 5 Yeah, these ones are the ones that I sent out last night when I said that there were some more problems from the College Board. The solutions and the problems are in there. Molly, would ln2 need to be written out numerically? No, ln2 is ln2. Just write ln2. That's not an algebraic expression. That's a numeric expression. Okay. So if you can use L'Hopital's rule to evaluate this, then we know that this must either be 0 over 0 or infinity over infinity. And we're looking at the limit as x approaches 5 of this. So first let's plug in 5, and we get 5 plus plus 5 times the cosine of pi. And in the denominator, we get 3 minus the square root of f of 5. And cosine of pi is -1, so the numerator is 0, which tells us that 3 minus root f of 5 needs to equal 0. Otherwise, we wouldn't be able to evaluate this using L'Hopital's rule. So 3 minus root f of 5 equals 0, which tells us that root f of 5 is equal to 3, or f of 5 is equal to 9. Pretty good with that? Okay, and then the second part of it asks us to find f prime of 5. So what we'll do is we'll actually use L'Hopital's rule to evaluate this. And so we'll have the limit as x approaches 5 of the derivative of this, which is derivative of x is just 1, and the derivative of 5 cosine pi over 5x should be minus pi sine pi over 5x over, and then the 3 goes away, and the derivative of negative root f of x is negative, is -1 over 2 root f of x times the derivative of f of x, which is f prime of x. One second. I'll be right back. All right, I'm back. Sorry about that. Okay, so we're going to evaluate this. The numerator, pi times the sine of pi over 5x. When we plug in 5 to that, that's the sine of pi, which is 0. So the numerator is just 1 over -1 over 2 times the square root of f of 5. And f of 5 was 9, so this is just -1/6 f prime of x, or f prime of 5 when we plug in the 5. And we need to recognize back from the original problem that it says f of, sorry, we're looking at g. This is g, right? Yeah, g of 5 is equal to 1. And that these functions are all twice differentiable. And if a function is differentiable, then that means it's continuous. So according to the definition of continuity, if the function is continuous, then the limit at every single value is equal to the value of the function. So if g of 5 is 1, then the limit as x approaches 5 also has to equal 1. So we then know that 1 over -1/6 f prime of 5 needs to equal 1. So we'll just solve for f prime of 5. That gives us f prime of 5, when you multiply it over, is 1 over -1/6, which is -6. Any questions there on the second part of that question? All right, Shayla. Sorry, I can't see all your questions. I gotta move the chat back over. Shayla, it says that it's twice differentiable. It doesn't matter that it's twice differentiable for the fact that it's continuous. If a function is differentiable, then that means that the function is continuous. And so since the function is continuous, the limit as you approach any value has to equal the value of the function. Does that make sense, Shayla? Okay. And Melinda, couldn't I just use the quotient rule since I know G prime? Let's see, I know G prime. Yeah, I know G prime of 5, but you mean use the quotient rule to evaluate the limit? You can't use the quotient rule to use L'Hopital's rule. It's just the derivative of the top and the derivative of the bottom. Oh, you mean find G prime. I see what you're saying. You say you could take the derivative of G of X to find G prime of X. No, that won't work because that's going to give you F prime terms. That'll get way too complicated. That won't work out. So. Other questions on that?
Can you prove it for YouTube? Because I have something to do on it.
1 second again. All right, sorry about that. I'm back again. Let's see, what are people saying here? I mean, yeah, I think it's possible, Jack, that the questions will look like this. This is what they released as their most recent like practice stuff for you. So hopefully this all makes sense to you guys. I mean, I can't promise what it's going to look like, but this is the best I can do. This is what they've given to us to practice. Plus, they suggested some other questions from last year's test. And I'm planning on doing those ones today at 2 o'clock. Some of them are very similar to these. And some of the parts are even like completely overlapping. But yeah. And yes, Tina, I'm recording them. At least I'm pretty sure I'm recording. It says it's recording. And yeah, the one that I did for first period is already saved. So I should be able to put them up sometime after this one's over. So. Yeah, Molly, the questions that I'm going over at 2, I sent out the link to, when I sent out the one that was like, here's a 25-minute long one, at the bottom of that link, there was suggestions of 2 other questions from 2019. They didn't have the questions on the page. You just have to search in Google for the 2019 questions. And I believe it was numbers, I want to say it was 4 and 6, but that might have been what the BC ones were. I can check real quick if you want me to. Let's see. Yeah, Molly, it's 2019 FRQs 4 and 6. Okay, 2019 FRQs 4 and 6 is what we're going to do at 2 o'clock. So if you just search for those on Google, you'll be able to find it. Let's see here. Jonathan, are sine and inverse tangent to No, you need to simplify, like the sign of a number needs to be simplified. As long as it's like if it's a unit circle value, simplify it. Don't leave it as sine of pi over 2, put 1. Don't leave it as inverse tangent of 1, write it as pi over 4. Priscilla, yeah, washers and discs is applications of integrals, and they're not covering that this year, so you don't need to worry about that. And we talked about that last time. Any other questions at the moment? Jack, did I say that mean value theorem for integrals wasn't on the test? I don't remember saying that. I'd have to go check on that. I know I put it on.
Yeah, you did say that.
I did. Okay, 1 second. Let me. That's not it. I'll have to check on that again. I got logged out of College Board, so it's hassling me to get back in. I'll check on that and let you know. Yeah. Other questions? When I say the second practice test is harder, let's see, what was that? I gotta go look back at the first one. Yeah, that problem is pretty easy. Yeah, probably so. I would say the second one is more difficult than the first one. But they're both doable. We already did most of this one. They added this extra velocity of a particle part into it that wasn't in the question that they'd originally given out for you to practice on. But it only affects a couple of the parts of it. It only affects A and B, which, that's a product rule derivative, which is pretty straightforward. And actually, it didn't affect B. I think B we already had. So they kind of combined some stuff together. But that question was pretty straightforward. And then the related rate one there, that's also a separable differential equation, was pretty easy also, I think. I mean, it's hard to say, Adrian. I would guess around 75%, 70 to 75% is good enough for a 5, yeah. Somewhere in that range is right on the borderline, as it usually is every year. I don't think it's going to change much. But, this is unprecedented, so it's hard to say with certainty. Well, Sean, generally a 3 is somewhere in the 45 to 60% range. Generally. Then the integral of the square root of 9 minus x squared. That one is, now there's, let me insert another page here. The integral from -3 to 0. Yeah, exactly. And that one's a semicircle. So what they want you to do there is to evaluate that. This is a semicircle that's centered at the origin with a radius of 3. And so if we're looking for the integral from -3 to 0 of this, they just want you to understand geometrically that that's a circle. That's the equation of a semicircle. The integral is the area under the curve. And so from -3 to 0, that's just a quarter of the circle. So it's 1/4 pi times the radius squared, or 1/4 of pi times 3 squared. There's another way to evaluate that integral using a trig substitution, but that's not something that we cover in AB. So they want you to do it that way. I mean, it's pretty easy substitution to do if you want to actually figure out the indefinite integral of it, but you shouldn't need to. And if you absolutely had to, you could, have a calculator do it for you on the test if for some reason they put that in, but they shouldn't because it's not AB material. So other than, if it was something similar to that, but it wasn't a nice semicircle. Other questions? And Jordan, I can't imagine that they're going to have you use those those summations to actually evaluate the integral. I think you're just going to need to be able to convert between the two forms. And I can't remember, did I put on the test review sheet, did I put in the formulas like how to find delta x and how to find x sub k to convert back and forth? I'm not sure if I did. If I didn't, I'll add that in. Yeah, I think I forgot to put those in. So I'll put that in, and I'm also putting in some of those important limits that you should know. People ask first grade. So I'll get both that stuff in today and resend that with a new link. Hopefully that sheet is helpful, but that sheet's only going to be helpful if you look through it first, right? Because otherwise you're not going to know what's on it, and you're just going to be floundering around trying to find stuff. You need to have a basic idea of what you're doing, and then you can use that as reference to help give you confidence in your answer, or to help you out if you forget if the, left approximation is an over approximation, if it's increasing or decreasing, those kinds of things. Just use it as like a reference for you. Don't look through it for 20 minutes trying to find one particular thing to solve one part of a problem, then you're screwed. So. All right. Any other questions, or should we take a break till 2 o'clock and then go and do a few more problems then? Chun, you shouldn't have an AP test at 2. The last AP test starts at 1, and they're only an hour long at the most. So if you're in the AP government class, you'll be done by 2, Chun.